So we're going to talk about the law of sines, and this is actually the law. It's A over sine A is equal to B over sine of B, which is equal to C over the sine of C. Now, when you draw a triangle, and you've had a handout on this, but we'll go over it again, this angle in here or this angle in here, or this angle in here, we label them with big letters. So this would be angle A, angle B, and angle C. So then this side across from there would be little a, little b, and little c. And that's how it works. So all the angles are capital letters and all the sides are little letters. So you can see how this law is going to work. All it is you take the side across from an angle. So you take an angle and the side across from it and compare it to another angle and another side across from that angle. So let's take a look and try it. And actually this law is for triangles that, it works on triangles that aren't right angle, which is nice because all the laws we've covered up till now are just for right angle triangles. So let's draw our triangle. So it's going to look like this. And we're going to have this angle is 47 degrees. We're going to have this angle as 63 degrees. And we're going to have this side as 13.8 meters. And we don't know what this side is. So all we do, and actually this is what you do every single time you do the law of sines, is you just kind of ignore the third term. Okay, it's in the law, but what the law is really saying is you can compare an angle and a side and an angle and a side. So we're just going to say A over sine A is equal to B over sine B. Okay, it doesn't even matter what letters are in here as long as you're comparing an angle and the side across from it. So what we can do is just write, okay, so let's say this thing we're going to say is A. So we're going to say X over, because X is across from A. So we're going to have X over sine of 47 degrees is equal to, let's see, B is 13.8 meters divided by sine of, and B is the angle across from it, so we're going to have 63 degrees. And that's just how simple it is. Every single time this is what you do. You always use sine, right? It's called the law of sines. I've seen people try and change these into cosine and tan and stuff. Don't do that. Okay, just use sine because this is the law, right? It's always sine. So what we're going to do is just solve for x. So we're going to let's see here what we want to do. Let's multiply this across to get rid of this on the bottom. So we're going to multiply by sine of 47. So that cancels those out. Multiply by sine of 47. So then x is going to equal 13.8 divided by, and sine of 63 is 0.891, and then that's going to all be multiplied by 0.731. And when you work that out in your calculator, that's just going to equal 11.3 meters. And that's just how easy it is. Every single law of sines question is exactly this same kind of thing. So let's try another example. So here's our example. This time it's going to be an upside down triangle. So we're going to have, and I'll label these sides just to show you how it works. So they're different letters, but we don't really care. Okay, we don't care what letters they give them. So let's see, 40 degrees, 14.3 meters, and 11.7 meters. All that we care about is that we know our formula is this. So A over sine A is equal to B over sine B. Okay? We don't care what these letters are at all. All we're doing is looking at an angle and the side across from it. So the side across from it, let's just call this one A. Okay? Let's just call this one. And so we're going to say 11.7 divided by sine of 40 is equal to, and actually the question is solve for angle E, which is just this. Okay? So we're just going to be solving for this angle. We don't care that it's called E at all because we're just going to put it into our sine formula. So into the law of sine. So the side across from that is 14.3, and then we're just going to say sine of theta because we don't know that theta. That's what we're going to solve for. So now all we need to do is get theta by itself. So there's a few ways we can do this. You can actually just do this yourself with algebra, but I'll show you how I would go about doing it. So the first thing I'm going to do is get theta off of the bottom. So I'm going to multiply by sine theta, which cancels that out. Multiply this side by sine theta. So then what I have is sine theta times 11.7 over sine 40 is equal to 14.3. So sine theta multiplied by, and if you take 11.7 and divide it by sine of 40 in your calculator, you'll get 18.2 is equal to 14.3. So we're going to divide by 18.2, which cancels that out, divide by 18.2. So sine of theta is equal to 0.786. Now all you need to do to get theta by itself is take the sine to the negative 1 of this stuff and sine to the negative 1 of this stuff. So we're going to say, because those cancels out the sine on that side, so theta is equal to 52 degrees. So that's what the angle in here is 52 degrees. This is what you do every single time. All you're doing is comparing an angle and the side across from it. So an angle and the side across from it, and then another angle and the side across from that angle. All you do is compare them and use algebra to solve for the thing you don't know.